Hello everyone! In this video, we will continue to examine topic 7.3, the structure of matter, and in particular, we'll be focusing in on exchange particles and Feynman diagrams. All right, so we have a lot of sort of the tools and the vocabulary we need to begin actually sort of applying some of this basic understanding of particle physics to sort of diagram and predict outcomes. The conservation laws in many ways are sort of our first real tool for, predicting outcomes. But we have one more that we're going to go through sort of systematically that can be very helpful. So let's dive back in a little bit and simply ask the question, all right, how do two electrons interact? Now, the classical answer for electrons was in the discovery of electricity and magnetism, and in particular, Coulomb's law, which we now know to be sort of an interesting mathematical approximation that works in a lot of cases, but perhaps does not accurately reflect the nature of the electromagnetic force. And in particular, the electromagnetic interaction, properly understood according to our best physics, is not a force at all, which is good because right before the invention of quantum field theory, we discovered that electrons were not necessarily point particles in their most fundamental nature. Now, the theory according to which two electrons interact, that is sort of the first quantum field theory articulated, came from Richard Feynman. It is known as quantum electrodynamics. It is the quantum field theory of electromagnetic interaction, full stop. And he came up with a way of representing the interactions that occur in quantum electrodynamics, which is a pretty hefty mathematical theory, using what are known as now as Feynman diagrams, which are little pictorial representations of the interaction itself. Now, in the full theory, this pictorial representation can be used to predict probabilities of scattering or certain interactions, and so there's a deep, deep tie to the diagram in the mathematics of the theory that we aren't going to discuss at all. And in fact, usually what you read about this is that interpreting the Feynman diagrams as a pictorial representation of what is happening is actually not particularly good physics for a lot of quantum reasons. For one, it sort of images or represents, these particles as if they were point particles and not according to our best understanding of the field theory that underlies them. So the diagrams themselves at their most fundamental level are A, both very useful, and B, explicitly not supposed to be used for what we're about to use them for, which is sort of a representation of what is happening. But that's okay. When you get to it, as I'm sure you will, you can discover sort of what is misleading about it. But for now, we will interpret this as sort of a quick sketch of certain kinds of interactions. Now, what is going on here? Well, in a normal Feynman diagram, one of the axes will be the position and one will be the time. And so what we're seeing in this particular one, and we'll see many more in the future, is one electron moving forward in space, so that's this way, and also in time. Okay, so this electron is sort of moving in space, sort of in one direction. And then it emits a photon. That's the red representation right there, given by gamma. And when it emits the photon, it is scattered, so it ends up sort of moving off in another direction. That photon then goes on to interact with another electron over here, and that electron absorbs the incoming photon and moves out in a different direction. What this is, at its most fundamental level, is a diagram of two electrons interacting, and in particular, more or less bouncing off each other. And how do they bounce off each other in quantum electrodynamics? Well, what happens is that the first electron exchanges a photon with the second electron. That photon carries energy and momentum, and so the photon is understood to mediate the interaction. It is not a force. Forces are gone. What happens instead is that the electron can emit that photon, and this electron can absorb it, and that photon is carrying energy and momentum, and in fact sort of shifts the trajectory of both of the electrons in that interaction. And this diagram, this Feynman diagram, shows us how that works. We will see many more over the course of the rest of this unit, but this is our first example of what is known as an exchange particle, which I will introduce in the next video.